Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. We continue looking at conditionals, and in particular in this video we're going to talk about comparisons and comparison operators that you can use between values. So in the last video we wrote code that used if. We wrote one version that uses it as a statement and another that uses it as an expression, and in both we had this little bit of logic right here where we said age less than 21, and we ran that in the RAPL and saw that when you do comparisons, for example 34 less than 21, which of course those are both hard written numbers, that's definitely false, that it gives you back a Boolean value, and that is what we need inside of our if. Now in the case of less than, it looks and it types out exactly the way you would expect it to be. Same is true for greater than. Both less than and greater than are just the symbols that you're used to typing. What if you want to do less than or equal to or greater than or equal to? Well, turns out that that winds up being two characters, and in many ways it's typed in the way that you would read it. You say this says 34 less than or equal to 21. Okay, that's happy. The equal sign does not go first. That is not happy. So in both cases, for both the less than and the greater than, you should type it in the way that you read it. Less than or equal to and greater than or equal to, with the equal following the less than or greater than. What if I want to check for a particular value? So let's go back and do something like that. And I want to see if age is equal to 23. Now we've already seen that when you have a single equal sign, that is not doing a check to see if two things are equal. It does not give you back a Boolean. Instead, it is doing an assignment. It is changing something, and that works with vars, but not with vals. So what do we want to do, or what do we have to type in to ask the question, is age equal to 28? And it turns out the answer to that is to use two equal signs. So a single equal sign is a statement of assignment. It stores the value that appears on the right-hand side into the variable that is on the left-hand side. If you want to do a check to ask the question, is something equal to something else, you use two equal signs for that. You also occasionally want to say the opposite. You want to say if something is not equal, and that comparison is an exclamation point followed by an equal. It can be read as bang equal. We typically read the exclamation point as bang because it has a lot fewer syllables to it. And so that is read as age is not equal to 28. You'll see that bang represents not in other ways in the next video that we do. So those are your basic comparison operators, and I have been doing them here between integers. What about for other types? Okay. Well, you can do this between strings too. Now, when we were talking originally about operators like plus, we said that plus was actually just a method that you call. And it turns out the same is true for these comparisons. Okay. That there is actually a method that is the greater than symbol, and there is a method that is the less than symbol. And those are defined on integers, they're defined on doubles and floats and chars. They are also defined upon strings. Now they are not going to be defined for absolutely everything, but for the types that are built in where it makes sense to say that one thing is less than another, you can do it. One of the types where it does so, for example, A less than B, makes sense. You might find this a little bit odd, the fact that lowercase a is not less than capital B. But if you remember that all of these have numeric values to them, what you're actually comparing is their numeric values, and all uppercase letters have smaller values than all lowercase letters. And that is why you get that result. In fact, we can see that here if we change it to a capital high. Oh, wait, sorry. Let's change this. Yeah. Change that to a capital A, and now we get true, because the capital A does come before the lowercase h, whereas then the capital H does not. So you can do this for strings. You can do this for chars. It's not necessarily defined for all of the basic built-in types, though. They've defined it for Boolean, and for Boolean, the true has a larger value than false. There's another type called unit that you really couldn't do comparisons with. And when we create types of our own later on, there will be things that we can't really do comparisons on. The comparisons have to be defined for the types. And in the second half of the book, we'll look at how we could do that with our own types. Now, this gives us enough information to start writing a more interesting example. And what I want this example to do is, so print line, enter an x coordinate. Val x equals read double. I will copy 2 lines there and paste and change these to be y. So what I want to do is I want to read in an x and a y coordinate, and I want to have this program tell us whether or not the value is in the first quadrant, second quadrant, third quadrant, or fourth quadrant. This might be something that you remember from an algebra class when you have a set of axes. Both being positive is the first quadrant. When x is negative, it's the second quadrant. When both are negative, it's the third quadrant. And when only y is negative, it's the fourth quadrant. So I want to print out first, second, third, or fourth based upon those conditions. And so I need to have some ifs. So the first if that I'm going to do is I'm going to do an if to check the x value. If x is less than 0, well, that means I either have to be in the second or the third quadrant. And if it's not, then I am in the other. So as we saw last time, I'm going to put in some curly braces here to define blocks of code. This is where things get a little bit more interesting, though, in that even inside of this block, there's still 2 conditions. When x is less than 0, you could be in the second quadrant or in the third quadrant. And which one you're in depends upon the value of y. Inside of the if, I can nest another if. This is one of the very powerful things about many programming languages, and it's definitely true of Scala. Scala allows you to nest basically every construct inside of every other construct. And that allows you to build much more powerful programs with a very simple set of rules. If you have an if, you can stick another if inside of it, and you can stick another if inside of that. The other constructs that we'll learn about later, you can stick those inside of an if, and you can stick an if inside of them. So this ability to nest things in whatever way you want allows you to build more complex logic. So if x is less than 0, and in addition to that y is less than 0, well, then that means that you're in the third quadrant. And so I'll just print out third. Else second. And now I can copy these 5 lines of code because I need to do something very similar here. This is the case where x is not less than 0. X is positive. Well, if x is positive and y is small, then we're in the 4th quadrant. Otherwise, we are in the 1st quadrant. In case you're wondering what I'm doing there in VI, I hit capital R for replace so that I can overwrite stuff. Now we can run that program. Thing to note about read double is it wants a single number on a single line. So if I type in something space something, it's going to break. So that's why I had it prompt for the x coordinate first. Okay. I gave it 2 values that are positive, so it's in the 1st quadrant, -4 and 36. Okay. And that would be in the 2nd quadrant. Okay. So here we have done, and technically all we did were less thans. We could have done more complex things. These could have been less thans or greater thans or whatever. I could have structured the logic differently so that the 1st and 4th were here at the beginning. They were the 1st case, and the others were in the 2nd case by using a greater than or equal to. But this hopefully lets you see a little bit more about the usage of if. You've seen the different comparisons that you have. You should try writing some code. Once again, write a little bit of code to help yourself understand these things. If you just watch it being done and assume that it's going to stick, it doesn't work because the details matter. The location of every parentheses and every curly brace winds up being significant, and as opposed to memorizing where those go, because of course they're different for every program, you need to kind of internalize the rules for where those things should be. And then if you understand the rules, you understand why it makes sense, why they should be there. So that's it for this video, and we'll come back next time and we'll learn how to make bigger, more complex Boolean logic statements that involve multiple comparisons.